Hey guys, I hope that I'm live right now. If you guys are able to listen me properly as well as there's no issues with the audio or the video, please do let me know. Hello everyone, I hope that I'm live right now guys. If you guys are able to listen me properly as well as there's no issues with the audio or the video, please let me know. Everything is alright, no issues with the audio or the video, right guys? Everything is fine? Great, awesome guys, awesome. So how are you guys? Is everybody fine, good, great, amazing? What is the scenario? How was your day? How was your day guys? Great. Okay, that's good. What else? Good, fine, bad. What happened? Shanti, what happened? Slept the whole day. Even me. I had a holiday today, so even I slept the entire day itself. So I think so we are on the same plane, I guess, right? Boring. Okay, okay. Hectic week. What happened, Aman? We have papers. Oh, that's sad to hear. But nevertheless, all the best for your papers. Okay. Okay, guys. So today our aim is to implement the CNN that we have learned yesterday. Okay, like a practical implementation sort of. So that is what we'll be focusing upon in our today's class. Will that be fine with everybody? Please let me know. Tomorrow we are going to start with a new topic that is YOLO. Okay, so YOLO is going to be used for our object detection that we are going to build, the app that we are going to build, guys. So today would be the last day of basically understanding all the technologies that go behind YOLO. Okay, so YOLO is an advanced format of CNN itself. So you look only once. That is the basic meaning of YOLO. Okay. So the YOLO algorithm will be learning it tomorrow and then we'll be implementing it day after tomorrow itself. So that is what we are going to focus upon in this particular class. Okay guys, yesterday you were able to understand what is CNN in like a crux itself. Please let me know. Were you guys able to understand CNNs a little bit in our yesterday's class? Please let me know guys. Yes, everybody was able to understand CNN in our yesterday's class. Okay, good. So today we'll see a practical implementation for that, guys. This is very important to see. An understanding about a concept is good. We are not able to deep dive into the concept because just one day is not sufficient for learning CNN in its entirety. Of course, that is true. But a little bit of conceptually, you are able to understand an intuition behind the algorithm. That is what I want from you guys. And today we'll see it practically. Okay, we're going to use a particular dataset called as the MNIST dataset. So let me share my screen with you guys. Let me do that for you. Share screen, entire screen, share. Let me bring myself down. Let me get your chat as well right over here on my screen. And this is the chat right over here on the left hand side. And MNIST dataset. Okay, so we are going to look into this particular data set, guys. So this is a very old data set, to be very frank with you guys. Very old data set that is there. This data set was originally created for banks. Okay, in banks you guys have something called as checks, right? Do you guys know checks in banks? Like checks, you can sign a check and you write an amount on that, like okay, 1,30,253 rupees only, and then you deposit that into the bank to get the money, right? So these numbers that were written on these checks were handwritten numbers. In that particular time back in 2000s, okay, there was no particular 1990s, there was no particular way of actually converting those handwritten digits into actual numerical objects, guys. So that is where this concept came into place, that okay, we need a particular software that is able to read handwritten digits. Okay, Akshit, you cannot do anything about it. If you have missed a class, you have missed a class. Focus upon the current class. Don't be there in the past itself. Okay, there's no point. There's nothing that I can do about it. There's nothing that you can do about it. Just focus upon the current class. That will be my suggestion to you. Okay, so right over here, guys, this is a data set that contains of more than 60,000 different handwritten numbers. Okay, that is the data set that is currently there. 60,000 handwritten numbers, and these numbers look something like this. So let me just open this up for you guys. I'll just go to this particular page. So as you're able to see, this is the format in which the numbers are there in different particular ways that you can write zeros, ones, 3 to 9, right? And these are all handwritten numbers. And like I said, there are 60,000 images such as this. Each of these images that is there, so each of the image is based, so as you're able to see, it is a 60,000 images. That is the training set on which the data is going to learn, and there is a test set of 10,000 examples which you can test the particular algorithm whether it is working fine or not. And so there is a total number of 70,000 images right over there. Each of these images, for example, the 3 that you are able to see, just this 3 right over here, is basically a 28 by 28 pixel image. Okay, it is basically a 28 by 28 pixel image, so 28 pixels in the length and 28 pixels in the width. And again, these are black and white image, so there is no RGB values, there is just black and white in nature. So it is from 0 to 255. That is how the images basically perceive themselves. Are you guys able to understand these images? Please let me know. Are you guys able to understand the dataset itself? Again, guys, the dataset comprises of 70,000 net number of images. 60,000 of them is the training set on which the algorithm is going to train itself. 10,000 images is the testing set on which you can test your algorithm whether it worked correctly or not. Each of these numbers individually is one particular image, and the size of each of these image is 28 by 28 pixels. Okay, that is a gist of the dataset that we are going to use in today's class. Again, where we are going to code, guys, Colab. So I'll just open up Colab for you guys, colab.research.google.com. That looks like a very big URL. So let it open up. Yes, Mr. Yusuf, what is the question? We use same code mostly in CNN just by changing the data set. Yes, Yusuf, you can think about it in such a way, but not in that simple terms, because again, the inputs that are going to be there, that is the images and everything, that vary a lot, right? For example, if you're using an RGB valued image, it is not just your length and width. There's a depth to the image as well, which contains the values for the R, B and G channels itself. In a similar manner, the size of the images might differ. In a similar manner, as soon as the size of the image differs or the number of channels differs, you'll have to improve your architecture a little bit. You'll have to add more number of neurons, more number of layers, more number of max pooling layers as well. So the architecture of a AI model depends upon what kind of data you are utilizing. If it's a very complex data, you will need a complex algorithm as well. If it is a very simple data like an MNIST data set, it will require a simple model as well, simple architecture itself. Okay. Okay. Are you guys able to understand what I said right now? Or did it bounce off? Yeah, Yusuf understood it. Great, Yusuf. Okay, so let me open up Colab. It is taking a few minutes to open up. Let me connect it to the particular server so that we are able to start writing our code itself. I don't know why my mom is messaging me right now. Let me just check her message. Otherwise she'll scold me that you don't look at our message, guys. Okay, so my friend is actually coming up on YouTube right now. So she sent me the particular video to that link that please do watch it. I'm like, okay, okay. In class right now. We'll watch after class. Let me just ask her that by the way, I am also on YouTube. You can watch me as well. Okay, so I'm like, dude, like, I'm also on YouTube right now. You can watch me as well. So today, no gali galoj, guys. My mom might be there in the live chat, so I have to make sure that there's no gali galoj in the class. Shit. I'm in class too. Will watch after class. My brother is like, I'm watching the class as well. Okay, so let's continue from right over there, guys. Today we are going to focus upon creating our first CNN architecture, guys. So first of all, what is the first thing that we need to do, guys? What is the first thing that we need to do? Let me know from your experience with ANNs. What is the first thing that we need to do? Let me know through your experience on ANNs itself, okay? What's the first thing that we need to do? What do you guys think is the first thing that we need to do, guys? Again, guys, import packages. Okay, great, awesome. We need to import the libraries that is required for the current particular algorithm that we need to create. The first particular thing is import numpy as np. Great. Oh, my import spelling is so wrong. Import numpy as np, guys. Okay, the next thing that we need to import is import keras. Okay, now what we need to import is all the different things that are required for building up the CNN itself. So import keras.datasets. It feels very uncomfortable to code with a mic in between, okay, because I'm not like I code in random positions itself. There's a very uncomfortable position right over there. Sorry, from keras.datasets, that is my mistake. From keras.datasets, we need to import the MNIST dataset as well. That is the dataset that we're going to use, guys. Okay, that is something that Keras already has. सर आप पूरा बूट कैंप हिंदी में किया होता तो ट्रिपल वॉचिंग होती सच में. That's great to hear, but we have some international students joining us as well. We have students from South India. They don't know Hindi, right? So I have to keep the language in English. That is the reason why. And you are here not to learn something else. Okay, you are here to learn IT. I hope so. That is for your job roles itself. So when you are going for an interview or something, you will not be able to allow to speak in Hindi right over there. You will have to communicate in English. So you need to have a basic skill set of understanding and communicating in English to be able to understand stuff. Especially the technical things, I think so that learning it in English helps you a lot while answering questions in the class. Okay. So yeah, as there's one particular person from Sri Lanka. So we have people from Kenya, Sri Lanka, UAE, Spain that are also joining in the bootcamp. That is the reason why I teach. What is MNIST? Bhai, pura Ramayana khatam ho gaya. This person is asking what is Ram? Who is Ram? Dude, like sports info, were you not there in the class itself in the starting of the class? Like, please do let me know. Like, I've already told what is the MNIST. Like, I showed you the entire thing itself, right? Okay, so let's continue from right there, guys. From keras models, import, and we're going to import the model itself. That is what we require right over here. Again, my spelling of import is very wrong. Import and model is right. Then we are going to go further with from keras.layers, keras.layers import, and we're going to import the dense layer. Why am I writing the spelling of import wrong again and again? Import the dense dense layer. We are going to import some other layers as well, for example the input layer. This is a new particular way of doing things, guys. Okay, the input layer is something that I'm going to teach you guys right over here, so it is going to be new for you guys, so pay attention to that. From keras.layers, I can put it all in the same line, but the point is that it will then take up the entire thing. I don't want to do that. That's the reason why I'm putting this up in a new line itself. Again, guys, I don't have to. I can import the same thing in the same line just by putting a comma and then writing the next stuff. It will actually extend the entire thing, so I don't want that to happen. So I'm importing it in a separate line. Okay, conv 2d comma max POOLING 2D, and then we need the dropout layer, DROP drop, OUT dropout. I hope the spelling of dropout is right, and FLATTEN flatten. These are all the different layers that will be required. I will be making you understand what is the conv2D. That is basically the convolutional layers that we have talked about in our yesterday's class. The max pooling layers, I hope so that you guys remember from the yesterday's class itself. The dropout and the flatten layer are going to be new to you guys, so you don't have to worry about it. I'll be teaching guys right over there itself. Okay. And okay, so moving on with the layers, we have already imported it. The next thing that we need to import from okay, from KERAS, import back end as K. Now this is going to be new for you guys. I hope so. We are not going to use the backend as K itself. But yeah, let's see how that goes on. Okay, so let us import all these different things so that we have everything in our arsenal to use at the end of the day. The next thing that we're going to do is we're going to create the training and the testing data. Guys, remember, have I told you guys about the training and the testing data, guys? Please let me know. So let me explain this to you guys. I think so I have not exactly explained it to you guys. So let me do that for you. Okay. So there are three things inside of a data set that you can create. Okay. What is the main aim of the AI? The main aim of the AI is to go into the real world where real people will give an input to the AI and the AI has to generate an output, right? That is basically the aim of the AI. Think about this as your final exams. Think about it as your final exams, guys. Now, how can you prepare for your final exams? Again, let's understand. We have a guidebook right over here, which has somewhere around 500 questions and the answers associated with them as well. I will divide this guidebook into three separate halves. Okay, I will divide this guidebook into three separate halves, guys. Now, the first half will contain somewhere around 350 questions and answers. Okay, the second half is going to contain somewhere around, let's say, 75 questions and answers. Okay, 75 question and answers, and the last part is also going to contain 75 questions and answers. Okay, so the first half is what I'm going to use to train myself, to learn from. Okay, this is called as a training data set. This is what I'm going to use to learn. The AI is going to use these 350 question and answers to learn from it. This is where it is learning. It is going through every single question, every single answer to learn from that. The last 75 question and answers like my final test. Final test, guys. Before giving my final examination, before going out in the real world and giving my final exam, I'm going to take up a final test just a few weeks before the final exam to check if I remember everything properly or not, if I'm performing well in my final test or not. So I have the answers for that as well. I have 75 questions as well as answers. I'll just look at the questions, I'll write down my own answers, I'll compare it with the answers that I currently have. In that particular way, I will be able to figure out that, okay, to a question that I have not seen yet, how well I was able to perform. And I want to make sure that I am doing very well in this final test. If I want to make sure that I want to do very well in this final test so that I'm able to do very well in the final examination as well, I will take up a validation test as well. I'll take up a validation test as well. Just before the final test, I'll take up another test for myself again to check whether I did good or not. And then also think about it as the validation data test is something that you take up before the final test. Your final test is basically your final test. After that, you have to go into the real world and give the final examination itself. Now, for our purpose, for this particular example of the MNIST dataset that we are going to use, we don't have a validation dataset, guys. We don't have a validation dataset. We only have a particular training dataset and the testing dataset. So that before going to the final exam, before going our AI going to the real world, taking up real handwritten numbers itself and producing an output of it, we are able to check whether we did good or not in the final examination. Are you guys able to understand this? Please let me know. So the entire data set, the MNIST data set itself, okay, MNIST, MNIST data set that we are having right now is already bifurcated into the training data set. Like I said, 60,000 images in the training data set and the testing data set, which has 10,000 images right over there. The training data set is going to have two parts to it, okay, the X train and the Y train. X underscore train and Y underscore train. The X train basically contains the images, okay, and the Y train basically contains that, okay, this image is 1, okay. In the same way, the testing dataset will also have two separate things, the X test and the Y test. Okay, again X test will again contain that, okay, this is 0, and Y test will then contain its numerical value, that is 0. That is the image and the value associated with that particular image. Are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Are you guys able to understand this, guys? Please let me know. Yes, amazing. So what we are going to do is we are going to decouple it. Okay, so we are going to write something like this that will help us decouple the entire training data set and the testing data set. Doing that is pretty simple in Python. Okay, this is the code that you have to write to create it. Okay. Again, if you want me to repeat it, this is a YouTube video, scroll back the video and watch it once again. That is how I will repeat it. Okay. So X underscore train comma Y underscore train comma X underscore test comma Y underscore test. These are variables that I am creating. You can name it as Shaurya Rakesh and Rakesh Shaurya as well, whatever you guys want to do. But this is what I am creating it. Again, guys, that is up to you guys. Is equals to MNIST dot load data parenthesis. So this is how you will be able to create your particular thing. Okay, X train comma Y train comma X test comma Y test, MNIST dot load data. This will load the data into these particular values. Why is X in uppercase? Again, this is a variable name. You want to write surveys right over there, you write surveys right over there. That is up to you. But usually when I am writing code, I put the X in capital, I put the Y in small. That is how I work. But again, that is up to you guys how you want to write it. Again, this is usually the format that I have been following for a very long period of time, so I keep that up. So as you're able to see, it has downloaded the dataset and it has loaded it up inside of these variables itself. Now what we're going to do is we are first going to check what is the type of this data. Okay, so let us do that. K dot, so this is the backend, guys. If you guys remember, we have imported the backend of Keras. Import backend as K. This basically helps to identify what is the type of the data that Keras is currently loading for us. Okay, so K dot image underscore data of underscore format parenthesis. Let us run this. Keras backend has no, I've written the wrong spelling of format. I'm very sorry. Let's run this. So channels last. Okay, so we are having the channels last format itself. So what we need to do for it is that we're going to write a particular set of so again, what do you mean by channels? Do you guys remember? I've used this term channels a lot actually. Like, I've not explained what channels are, but I've already used the term channels while explaining you guys something. Do you guys remember what channels are? In the image, what are channels? Why is this coming up on my nose? What are channels, guys? I've used this term channels while explaining you something about the image. But I've not explained you guys what channels are. I thought that by using the terms, you guys will be able to understand. That is absolutely correct, my Nick. Same, that is RGB. Your RGB values are also referred to as channels of an image itself. Here you are having just one particular channel, that is black and white image, so one channel itself. So here your dataset that is currently there is of the format of width, length, width, and your channel. That is one. Length, width, and your channel. So channel is basically last in the shape of the input image, guys. The channel is the last in the shape of the input image. That is what it is basically specifying right over here. Sometimes the images are shaped in such a way that the channels will be first. Okay, so it will come up as channels first. That means it will be 1, that is the number of channels. Right now it is a black and white image, so there is no RGB, there is just one particular channel, and then the length and the width will be there. So again, the shape of a matrix, if you guys remember, shape of a matrix, that is what it is specifying. Okay, when I am talking about like 1 comma length width, that is the shape of the matrix that we are using right over there. So here we will have to change something about the images, a few things about the images, guys. First of all, we are going to make sure that our particular matrix is of a certain shape. Okay, so we're going to use something called as reshape to do that. It's actually pretty simple, guys. We're going to use let me image img underscore rows rows is equals to 28. Okay, I'm creating two particular variables right over here, and img underscore col columns is equals to 28. Where is this 28 coming in from? Can somebody let me know why have I chosen 28 as the number? Why not 26? Why not 30? Why 28 is there? Can somebody let me know? Can somebody let me know? Why is 28 there? Why not 26? Why not 30? Because it is a 28 by 28 image. That means there is 28 rows and 28 columns, right? Very good, guys. Now here what I've done is I've created two variables and I've assigned the value 28 to them. I can do it in the same row as well. I don't have to make two separate things right over here. Comma image columns is equals to 28 comma 28. This will also do the exact same thing for me. Okay, this will also do the exact same thing for me. I don't have to like write two separate lines of code for it. Okay, so again, both the meanings of the terms are absolutely the same. There's no difference about it. Okay, it is what you prefer, that is up to you guys to use. The next thing that we are going to do is that, like I said, we are going to make sure that the image is of the right particular type. Okay, so x underscore train is equals to x underscore train dot reshape. Okay, we use a reshape to reshape the matrix. Even if the matrix was of another format, it will make sure that the matrix remains of the format that we want. Okay, so right over here, guys, we are going to do x underscore train dot shape 0 comma rows comma img underscore columns comma 1. Yeah, this is very irritating, man. That is the reason why I don't like to do stuff in so much zoom, because everything, I'm not able to see shit right over there. Yeah, but if I decrease the zoom capacity, then you guys are not able to see stuff right over there. That is the reason I don't like this. Okay, so what I've done right over here is that I've made sure that whatever the shape of the image is, it should remain image rows, that is 28 comma 28 comma 1. Okay, whatever the shape is, it should remain 28 comma 28 comma 1. That is what I've tried to do this. And the same thing we have to do it with the x test as well. Even if it is of 28 comma 28 comma 1, this will make sure that if there is certain problem with the with the data set, we are able to rectify it immediately. Okay, we are able to rectify it immediately, so that after writing the entire code, we are not stuck at what is the problem right over there. Our image is not getting loaded up into our AI itself. This will make sure that whatever inputs that we want to our AI is of the same format. Okay, is of the same format, guys. I'm very sorry I have made this error right over here. Thank you so much for pointing that out. Image col. Okay, thank you so much for pointing that out. I think so if rows is s, I think so columns should also have an s right over there. Let's just add an s right over there to all of these. so that everything looks a little bit better, because rows we have written it as, right? So we should have columns as well as plural. Okay, and let us take up the INPX as 1 comma img row comma rows comma img underscore cols calls. Okay, so okay, very fucked up. This is the current input shape that we have created our image to be in, 28 comma 28 comma 1. Okay, again explaining this to you guys. Currently, whatever the shape of xtrain or xtest is, what is the shape? That is how length, width, and the depth of the image itself. It is currently channels last. That means it is basically 28 comma 28 comma 1. Now, to make sure that even if there is any fault from the dataset, loading the dataset, or from our end, the image should always be 28 comma 28 comma 1. We are reshaping the xtrain to be of 28 comma 28 comma 1, and have created the input size of the like images. What is the input size of the image that we're going to feed into our AI as 28 comma 28 comma 1. I've saved it inside of this variable so that later on if you want to use it, we have the shape of our images already loaded inside of a variable. That is what I've done right over here. Now, if you guys remember, what is the values that is present? Okay, so this 0 that is there right over here, what does this denote? Can somebody let me know? Nobody asked me this question. I was actually pretty surprised, because I, like, by genuineness, I did not tell you guys what that 0 is. The reason for that is I wanted somebody to ask me that. Like, can somebody let me know, what do you guys think? Why is there a 0 right over there? Like, we could have just written xtrain.shape, right? Why is xtrain.shape 0 required right over there? Yeah, thank you so much for pointing that out. This is also required. Xtest.shape, do not write xtrain.shape. No. No. 0 picture at 0 index. Very nice. Okay, so what does xtrain actually contain? Let's try to answer this in such a way. What does xtrain actually contain inside of it? What do you guys think? What does xtrain contain? What does xtrain contain? The xtrain entirely surveys contains just one image. What does xtrain contain, guys? It contains 60,000 images of the shape 28 comma 28 comma 1. So xtrain.shape will be your 60,000 images actually. Let us do that right over here. Xtrain.shape. Let us run this. It is 60,000 28 28. It is 60,000 images of 28 by 28 pixels. 60,000 images of 28 by 28 pixels. If I just want the shape of just the first image, if I want the shape of just the first image, guys, what can I do? This is the problem right over here. Right now when you're doing xtrain.shape, you're getting 60,000 28 28. I want 60,000 28 28 and 1 as well. I want this 1 at the very end as well, guys. That is what we are trying to achieve right over here. So right now if I do x underscore train dot shape 0, this will get me the first particular element, guys. Okay, this is getting me the 0th. Okay, this will get me the first element. Sorry, 0. This will get me the first particular element, guys. 28 comma 28. That is my first particular element, guys. Xtrain 0 will get me the first element that is there. Again, why 0? Because Python is a 0th index programming language. When we count, we start counting from 1, right? Python starts counting from 0. Python, JavaScript, C++, C, C#, all these programming languages are 0th index programming languages. That basically means that they start counting from 0, guys. Okay, so at the 0th position is our first particular like picture. Our first particular picture is present at the 0th index. So that is how we are able to get the 0. And this basically, if we shift this dot shape and then we try to do 0, it will get us this particular value, that is 60,000. Okay, so we run this, it will get us 60,000 from here. If we run this as 1, it will get us 28 right over here, guys. That is the second particular element. So again, Python starts counting from 0. So this is present at the 0th location. This is present at the first location. This is present at the second location. If I try to do second right over here, it will give me again 28 as well. So 0 basically is getting us that 60,000, the shape of it. Okay. So xtest.shape will be how much? Can somebody let me know? Xtest.shape. What will be the value right over there? If I've understood what I've told you guys right now, what will be the value of xtest.shape 0, guys? What will be the value right over there? 10,000, right? Because how many elements does xtest contain? 10,000, right? That is what it is going to contain. Now, once I run this right now, and then I rerun xtrain.shape, as you're able to see, now we will be getting 60,000, 28, 28 and 1. We are also getting that channel value as well. That is the particular difference that we have created. What we have done right over here is added this one at the very end. That is the channel. How many channels are there? So xtrain.shape has now changed to 60,000, 28, 28 and 1. In a similar manner, the same will be happening for the xtest as well. If you check it up right over here, it will also show up as 10,000, 28, 28 and 1, guys. That is the change that we have done right over there. Okay, so let's remove this. And let us look at the first particular element, guys. Okay, x underscore train. And let us look at the first particular picture that is there, guys. Okay, so the first picture, as you're able to see, contains values of 0. Okay, and 0 once again, because this is a very big one. It contains values from 0 to 255. Okay, as you're able to see, it contains value from 0 to 255 itself. Why 1 is in reshape code at the end? Because how many channels are there? It's a black and white image, right? It's not a red, green and blue. If it was a red, green and blue image, then the channel number will be 3. By default, 1 is usually not written, but in case of creating an architecture, we want to be very specific about what we are creating. So to be very specific, we are having a 28 by 28 by 1 image. So we have to add that 1 at the end of the shape of our dataset as well. Okay, so like I said, guys, the particular image that we currently have has values from ranging from 0 to 255. Now there are two problems right over here. If we try to feed this particular image directly to our AI, guys, two big problems. First, because there is so much difference between 0 and 255, the AI might give preference to 255 much more than 0. It's actually one particular problem statement itself. This is the problem statement, that because 255 is such a huge value when compared to 0, your AI might get biased towards 255. Your AI might get biased towards 255 itself. Secondly, because 255 is such a big number when it comes to computation, when it comes to your matrix multiplications and everything, 255 will lead to a very heavy calculations that is going to be there in the background. We want as small numbers as possible so that there is faster computations, while making sure that the AI doesn't confuse that, okay, 255 is a larger number, so it has a lot more value than when it compares to 0. Both should have almost the equal value. They should be near to each other itself. So we want all these values that are there within the particular image to go from 0 to 255 to 0 to 1. How can we do that? Are you guys able to understand why this problem is there between 0 and 255? Why we do not want numbers between 0 and 255, guys? Two problems, guys. Two problems right over there. First, because if there is so much disparity between the two numbers, so much difference between the two numbers itself, then your AI might get biased towards 255. The 255 is greater, it has much more value. Okay. The second particular problem is that because there are so many computations going to go about in the background, so many matrix multiplications going to go about in the background, having a larger number means heavier computations, slower results itself. Okay. So how can we convert all these numbers from 0 to 255 to 0 to 1, guys? How can we do that? How can we do that, guys? Can somebody let me know? Think about it, guys. Think about it. I want you guys to think about it. I want you guys to think about it, guys. How can we convert these numbers from 0 to 255 to 0 to 1? Think about a particular easy manner, guys. If there is a particular number ranging, a set of numbers ranging from 0 to 255, you have to preserve those parity, but you want to make sure that the numbers are between 0 to 1. How can we do that? Just by divide it by 255, right? We just need to divide it by 255. It's as simple as that. If you divide all the numbers in these matrix by 255, you will get a particular, you will preserve the particular disparity while making sure that all the numbers are between 0 and 1, right? It's as simple as that. Now, what is the data type of 253, guys? What is the data type of 253? Can somebody let me know? What is the data type of 253, guys? Can somebody let me know? Integer. If we divide it by 255, are we going to get integers or are we going to get floats? We want floats at the very end. So let's convert it into floats and then utilize it. Okay, so to do that, what we're going to do is we're going to specify that right over there. Okay, the entire thing just loaded up. So we're going to do two things, guys. First, we're going to make sure that this is a float itself. So x train is equals to x underscore train dot as type. So you want it to represent it as a type of float 32. So 32 here basically identifies as 32 bit. Okay, so you don't know the concept of bits right now, but okay, that is not a very important thing. We are just representing it as a floating point number itself. So you can think about it in such a way. And then the same thing we're going to do with the x test as well. And then we're going to divide the stuff. So it is basically very simple. X train is equals to x train divided by 255. So it will divide all the elements that are there inside of x train by 255. The same thing we can do it with x test as well, guys. Just focus on this. X test divide equal to 255. Both of these lines of code actually mean the exact same thing. Both of these lines of code actually mean the exact same thing. Okay, you can represent it. X train is equal to x train divided by 255 as x test divided by equal to 255. It means the exact same thing, guys. So this is one of the other things in Python that I wanted you guys to know. Okay, so you don't have to write x train is equal to x train divided by 255. You can just write x train divide equal to 255. It will do the exact same thing for you. So let's run this particular line of code as well for us. So we have done that as well. The next thing that we're going to do is we are going to start creating the model itself. Before creating the model, we need to categorize. Why are we not applying the changes to these changes to a y train and y test? What does y train and y test contain? Mayank Sen, please do let me know, what does y train and y test contain? Does it contains the images? Does it contain the images, guys? What does y train and y test contain? Man, think about it. I've already taught you guys that. I've already taught you guys this. What does y train and y test contain? It contains the numerical values that are represented in pictorial formats. So if x train contains an image of 1, y train is actually the number 1. If x train contains an image of 3, y train will contain the value 3 itself inside of it. Now the problem is the output that is going to be there is not going to be in this particular format, guys. This is where things get a little bit interesting. Although, what can y be? Y can be any number from 0 to 9, right? Y can be any number from 0 to 9 itself, right? Are you guys able to understand this? Please let me know. how our AI is going to work is that it is not going to tell you exactly what number it is. Please try to understand it. So if I give an input like this, it is not going to tell me that, okay, this is 0 or this is going to be 6. It is going to tell me what is the probability of this image being 0. What is the probability of this image being 1? What is the probability of this image being 2? What is the probability of this image being 3? What is the probability of this image being 4? Similar to that 5, similar to that 6, similar to that 7, similar to that 8, similar to that 9, similar to that, that's it. Okay, that is all that it is there. So let's say the probability of 0 will be somewhere around like 70%. Okay, the probability of it being 6 will be somewhere around 25%. This will be 0%, this will be 0%, this will be 0%, this will be 0%, this will be 1%, this will be 0% again, this will be again 0%, this will be like 4% or something like that. Now the highest probability that is there is of 0, guys. When we feed this, so this is the output that will be there via the AI. This will be the output that will be there via the AI, guys. Okay. So out of this, what is the maximum? That is 0. That will be your final answer. So the output via the AI, the output layer of the AI is going to be this categorical values, guys. It is going to be these categorical values that for every category, what are the different category of outputs that is going to be there? It is going to be 0, it is going to be 1, it is going to be 2, 3, 4, 5, 6, 7, 8, 9. These are the different categories your output can be. So what is the probability of it being 0? What is the probability of it being 1? So what we need to do is that we need to sports info, just go do a Google search for that. It is a type. If I try to make you guys understand what is 32 bits, okay, it is going to be another lecture right over there that I don't want to spend. Okay, think about it as floats, but to a size of floats itself. So how much data your computer can handle. Bits is basically how much bits, bytes, then MB, then GB. Okay, that is the concept right over there. That is a separate thing. I'm not interested to start that entire lecture right now, but there's so many different things that is remaining. So if you want to understand what is floats 32 and floats, what is the difference between the two, just do a simple Google search right over there. Okay. So for every value, so right now your Y train or your Y test right over there, it basically gives you a particular value 0, right? I want it to be in a format of a categorical value. That is, the categorical value will be 1, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will be the representation of 0. For the representation of 1 will be 0, 1, 0, 0, 0, 0, 0, 0, 0, 0. The representation of 2 will be 0, 0, 1, 0, 0, 0, 0, 0, 0, 0. The representation of 3 will be 0, 0, 0, 1, 0, 0, 0, 0, 0, 0. The representation of 9 will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. So what is happening right over here? So for each of the categories, that is the category 0, that is the category 1, the 2, 3, 4, 5, 6, 7, 8, 9. These are the different categories that is there. What is the probability of a number being 0? If the answer is 0, we already know that. That means the probability of it being 0 is basically 1. And the probability of it being any other categories is 0. Similar to that, if a number is 1, we already know that. From the Y test, we already know that this number is 0, this number is 1. Then the probability of it being 1 will be 1, other will be 0. Similar to that for 2, similar to that for 3, similar to that for 9 as well. Right? So this, to be able to achieve, to convert our Y test into this particular format. Okay, currently it is just numbers, right? Sports info, dude, what is happening? Are you not paying attention? Did you go and to pee or poop in the middle of the class? Like what is happening right over there? I already made you understood, like why did we do x train divided by 255? I give you guys 2 examples to make you guys understand why do we need to divide it by 255. What were you doing at that point of time? Please pay attention in the class. Don't ask questions that I've already answered. Otherwise, what is the point of answering them? Right? Please try to make sure that you are able to understand stuff when I'm teaching. At that point of time, if you had a question, you ask it right over there. This is basically what I've already answered. I need to focus on the rest of the stuff. We are already going pretty slow for today's class. Focus upon the class, man. Okay, so right over here, guys, to do this directly, to convert all these X-trace test and Y test and Y train from these numbers into this particular format itself. Okay, guys, see, okay, I'm being very polite while answering to you guys, but I only have 7 to 9 days to finish up a boot camp. After that, there will be a new boot camp that will be starting up. I don't care. If you guys want me to repeat every single thing that I've already answered 10 times, I'll do that for you. But then don't tell me at the last day of the class itself that the project is not done. Just don't tell me that then. I will repeat everything 30 times. Like, I've already answered that question directly. You didn't even had to ask me that why are we doing divided by 255. I gave you guys 2 reasons, because that is something, this is not for sports info, this is for Harshita Dubey. And not being rude, I'm being practical. Because see, at the end of the day, you will sit in the class, you will go away. Then you will tell the other students that, oh, the project was not done, this is what is happening. We are already going pretty slow for today's class. You want to be slow? It's fine. Then don't complain, because you want to be slow. Then the rest of the students don't. I'm not being rude. I'm being practical. You have not seen me being rude. And again, I'm not a teacher. Please don't treat me as a teacher as well. Think of me as a senior. College ka senior. Okay? He will abuse you. He'll make sure that you are listening to so many different type of words that you have never heard in your entire life in your school days itself. But at the end of the day, he has your interests for first. Okay, at the end of the day. I'm not a teacher, guys. Don't treat me as a teacher as well. I don't like being a teacher. I like being a senior. Treat me as a senior. Be open with me just like you are open with your little bit elder brother or with your friend itself. That's it. Okay? Okay, let's continue from right over there. So to convert these numbers into such a categorical thing itself, Keras already provides you the tools of doing that. So we are going to use that particular tool itself to do this. Instead of doing this ourselves, let's do that for right now. Okay, and let's continue from right over there. Okay, so Y train, let's first convert that is equals to Y underscore train. No, I think so. I have written the wrong code. Okay, keras dot utils dot to categorical. Dude, come on, do not come in the middle, otherwise I'm not able to see. Categorical and then Y train. Let's do this same thing with our Y test as well. So I have not run this particular code right now. Let us first look at how Y train actually looks like. So this is how Y train currently looks like without running this code, guys. As you're able to see, it contains 5, then 0, then 4, then 5, 6, 8, and so on and so forth. Let's see how Y train looks like after we run this code. So let me run this code for you guys. Now let us run this same thing once again in a new line so that you are able to see the difference. Now as you're able to see, that has been, so this was 0, right? So the first one is 1, the rest of them are zeros, okay? This one was, okay, so it is showing for different numbers itself, but that is the basic concept right over here, guys. So all these numbers are now represented into a format that shows the categorical probability of it being that number. Okay, so that is the change that we have done right over here. Are you guys able to understand? This is the code for that, guys. Keras.utils.toCategorical. So again, Keras comes up with all these things inbuilt, so that is one of the benefits of it. Okay, so now what we are going to do is we are going to create the model right now. Okay, so INPX is equals to input. Is remember input that we have already, you guys remember? Or have you guys forgotten about it? Remember input, keras.layers, input dense, and input right over here. So input basically you just feed in the shape of your input images. You just feed in the shape of your input images, guys, that is the INPX that we had created, and it will create a particular input layer of that particular shape. Like, it will create a layer of neurons of exactly that shape for you. So that is the benefit that we are availing right over here, INPX. I hope I have written that in small letters. Let me just check it once. INPX, right? Okay, so INPX right over here, that is going to be our input shape of our first particular layer, guys. The next is going to be our particular layer 1, LAYER layer 1, guys. Okay, so LAYER, let us name it as layer 1 is equals to, you can put up a let's do that. Okay, why to do this? Okay, layer 1 is equals to conf 2D. Okay, and then we're just going to specify the particular thing. So how many filters do you want for our first conf 2D layer? Okay, again, you can specify the number of filters that you want. Here you have to specify the number of filters. Sports info, it's totally fine. I was not pointing it out to you. Please do not worry about it. Okay, I was pointing it out to somebody else. Just focus upon the class. Okay, why are we dividing it by 255? If you were not able to listen to it correctly, I'll just repeat it at the end of the class itself. Don't worry about it. Okay, so conf number of filters. You guys remember conv layer, we had filters right over there. Again, the number of filters needs to be also in 2 to the power n. Okay, so here we are going to specify 32 filters. Again, you can change it to 64 filters, 128 filters, depending upon what is your requirement. For our purpose, I'm taking up 32 filters itself. What is going to be the size of your filter? Okay, so that kernel size. Okay, I hope that I've written the right spelling. KERNEL, SIZE size is equals to, and we're going to specify a size by 3,3. That is the size of our filters that we want to set up. According to that, we need a activation function as well. So activation, we're going to use relu. If there is any kind of spelling mistakes, please do point it out, guys. Otherwise, usually I just like make a lot of spelling mistakes. RELU, that is going to be our conf 2D, and the shape of the conf 2D again is going to be INPX. There's not a shape, that is basically what is the layer that is before this layer 1. Okay, this is how we are creating the model this time, guys. This is a new way of creating the model. This is actually like the latest way of doing it according to TensorFlow itself. So right over here, what we are doing is we have declared this as layer 1. Okay, and this is the layer that is before that layer. So input layer, okay, INPX. I'm very sorry, this should be. Okay, so INPX is the layer before that, guys. Let us specify the shape right over here. Shape is equals to INPX. Okay, so here the input layer before that is there, so that is what we are specifying right over here, guys. Next we are going to have LAYER layer 2 underscore 2, guys. This is going to be again a conf 2D layers. Again we are going to increase the number of filters right over here, guys. So we'll just copy paste this entire thing. I don't want to write it once again, so Control C and Control V. We're going to increase our number of layers to be 64 layers itself, so number of filters to be 64 filters. Again we're going to have a kernel size of 3,3. Again we're going to have the activation function as relu. But the layer before the layer 2, what is the layer before the layer 2, guys? What is the layer before the layer 2? Can somebody let me know? What is the layer before the layer 2, guys? There are a lot of activation functions other than relu. Sigmoid activation function is there, tan activation function is there, step activation function is there. So layer 1, right? So YER layer underscore 1, that is the previous layer that is going to be there. Similar to that, we are going to have the next particular layer, guys, that is going to be the max pool layer. So LAYER layer underscore 3 is equals to max underscore pooling, POOLING, pooling 2D, and we are going to put up our pool size of 3,3. That's it. So POOL pool underscore SIZE size is equals to 3,3, and we're going to put up our layer 2 before that, LAYER layer underscore 2. And that's it, guys. So pool size is basically what is the size of the pooling filter that you're having on top of it. So again, 3x3 pooling filter, and layer 2 is the previous layer on top of it, guys. So that is what we have specified right over here. Now we're going to have the layer layer underscore 4. Okay, this layer underscore 4 is going to be a dropout layer with a dropout ratio of 0.5. Now what is a dropout layer, guys? What is a dropout layer? Can somebody think, like, what is the meaning of dropout? What is the meaning of dropout, guys? What is the meaning of the term dropout in normal English? Let's assume I don't know. Yeah, I've done some spelling mistakes or what? Max PWLING pooling 2D. That is the same spelling I've used, Max. To delete or to discontinue, right? Or dropping something, that to leave off, right? So school dropout. So basically you guys understand the meaning of the term dropout. Now there are so many different neurons inside of these layers, right? So the dropout layer is a layer in which random neurons will be dropped out. Random neurons will be shut off. Randomly, in every training, let's assume alternate neurons are shut off in that particular layer. So the features that were coming to those layers will just be killed right over there. They're not going to be propagated further into the architecture itself. In the next particular training, so there are multiple epochs, right? There are multiple epochs for training our particular model. So in every epoch, random neurons will be shut off in that particular layer. Random neurons will be shut off in that particular layer. Now this actually helps the AI not to memorize stuff. Because in every learning, random features are getting deleted. So even if it try to remember or memorize something, it will discard it. It will remove it. Because in every layer, something different is going to happen. Are you guys able to understand why do we use a dropout layer? Again, dropout layer means that in every particular epoch, 50% of the neurons will be randomly dropped off. Will be randomly switched off itself in every single epoch itself. Okay. Okay. Now we are going to go over into the layer 5, layer underscore 5, and this is going to be a very interesting layer. That is the FLATTEN flatten layer, guys. Now this particular layer is something that I think so you guys are listening about in the very first time. Let me explain it to you guys. layer underscore 4. That is the previous layer right over there. Okay, so till the dropout layer, what was the shape? Think about it as a kid, like kindergarten kid. You're a kindergarten kid right now, guys. Until layer 4, what was the shape of your neural networks? Think about it. If I give you a pen and a paper as a kindergarten kid, what shape would you draw when you are going to represent the shape of our neural networks, guys? Kindergarten kid does not understand numbers. What shape would you be drawing right over there? What shape would you be drawing right over there, guys? Would you be drawing a triangle? Would you be drawing a circle? Would you be drawing a line? Would you be drawing a rectangle? Would you be drawing an oval? What shape would you be drawing to represent the shape of our neural layers that are there till the layer 4? It will be a square, guys. It will be a square, right? Guys, this should be a no-brainer. Where the fuck is a oval and a circle coming in from? It's going to be a square, guys. What are you guys thinking? Like, the input shape was a image. It is a matrix. The particular layers that we are creating are conv layers that are basically like matrices on top of these matrices that are taking up the numbers and forming another matrix. How is a matrix a circle? Dude, come on, guys. It is going to be a square. How are you guys? I want people who have written square and oval to make me understand where are they thinking about squares and ovals. Please do let me know. For those guys who have answered as circles and ovals, please do make me understand how you guys thought about circles and ovals right over there. I want to understand it. Like, because there is something very wrong with your understanding. If I am not able to understand that and help you guys out, then you will not be able to move further with it. Please let me know why are you guys thinking about it as circles and ovals, guys. I need to understand where did that circles and ovals come in from. I'm not going to continue further with the class if I'm not getting the answers. I'm not going to continue with the card class, guys. If you guys are writing it as circles or ovals, guys. Because I need to understand what wrong is going on and like what were you not able to understand. That is the aim. It is going to be a square. Okay. Now to convert it, we need to, like I said in our yesterday's class, at the end of it, we need to attach a particular ANN that is going to do the final computations for this. Okay. At the end of it, we are going to have an ANN that is going to be there, a densely connected layers of ANN itself, artificial neural networks, that is going to be there to basically consume all these features that have come up as inputs and give us our final output, guys. Now, because up till the layer 4, everything was in fact a square cannot be given directly as an input to an ANN. So you use something called as flatten right over there. What does flatten do? It basically does what it is its name. It basically flattens out the entire thing. So if you're having this particular square as an input, it will take the second particular layer, it will take this particular layer and it will attach it right over here. So this will become like this. Then it will take this particular layer and attach it here. It will take this particular layer and attach it at the end. So this is how it will flatten the entire thing. This is how it will flatten the entire thing to make this particular single layered thing. So it takes the 2D and converts it into 1D. That is the reason why we call it as flatten. Because whatever your square was, or the square of features that you had created, it will basically flatten it up into a one-dimensional input that we are going to give to our ANN. That is what the flatten is for. Okay. Then we are going to have our two densely connected layers, guys. So LAYER layer underscore 6. That is equals to your dense, DENSE dense. What are the inputs for the dense layers? Can somebody let me know? What are the inputs for the dense layer, guys? Can somebody let me know? We have already dealt with it in our yesterday's class. What are the inputs that I need to provide right over here? Please let me know, guys. What is the different inputs that I have to provide to our dense layer, guys? Please let me know. Come on, guys, let me know. We have already learned in yesterday's class, guys. Yesterday, day before yesterday, we created the dense layers. Come on, guys. This shouldn't be so hard for you guys to answer. So regularizers we are not going to use in this particular thing, but yes, first the number of neurons, that is 256 neurons, we are putting it up right over here. Then we're going to have the activation function, we're going to have the activation function as sigmoid. Sigmoid activation function should be more than sufficient, and then we're going to have the previous layer, LAYER layer 5 underscore. Okay, in the similar way, we are going to create the output layer right now, guys. Again, the output layer is the LAYER layer underscore 7. How many neurons are going to be there in our output layer, guys? Can somebody let me know? How many neurons are going to be there in our output layer, guys? Guys, again, think what is the output right now? Think, guys, think. This is not the right answer. Think about it. Guys, think, come on, man. What is Y train? What is Y train right now? What is Y train? We have converted Y train into this. This is your output. Your output is the probability of every single category that exists. So your output right now is going to have 10 neurons right over there, guys. Your output has 10 neurons right over there, where every neuron is basically signifying the probability of that number being something. Guys, these are basically logical things. These are not something that you can learn. These are not something that is learned, guys. Soft max, guys. Okay, activation function is going to be soft max. I'm going to have layer 6 as the previous layer. We are going to create our model like this. Okay, so our model has also been created. Next, we are going to compile our model, guys. So we are going to compile our model. So model model is equals to model model inpx, that is the input from the input layer to the layer 7_7, that is the last layer, that is our output layer right over there. Then you are having your model dot compile, and we're going to compile our model right over here, guys. Optimizer, what optimizer are we going to use? To use a new optimizer right over here is equals to keras, keras dot optimizer optimizers dot ada delta. This is the optimizer that we're going to use. Next, we are going to use the loss. Which loss we want to have? Loss, how have I written it? No space. Okay, loss is equals to keras dot losses losses dot categorical cross entropy categorical cross entropy entropy, and that is the loss that we're going to have. Again, next, METRICS matrix, we are going to have it as accuracy, ACC QRACY accuracy. That is going to be a compile. We are going to fit our model with the data set itself right now. Model dot fit x train comma y train comma how many epochs should we have, because let's have 15 epochs. Let's see, epochs epochs is equals to 15. 15 would be very high, but okay, it's okay for us. BATCH batch underscore SIZE size is equals to 500. Okay, let's fit our model right over here. Let's train our model. Okay, so right now our model is training. It is going to take it, I think so, almost 5 minutes to train. Let us change the number of epochs to be 12. Otherwise it will go on for a very long period of time. Let me rerun this. Stop. Let me rerun this with 12 epochs. Okay, so it is going to take us 5 minutes to run this, guys. In the meanwhile, I will write the code already for our testing purpose. SCORE score is equals to model dot evaluate, and we are going to evaluate as is my spelling of evaluate correct? EVALUATE. I hope so, it is correct. And we're going to evaluate against x test, test comma y test. That is how we are going to evaluate as verbose is equals to 0. And we're going to have the scoring as well. So print the accuracy as SCOR, score 1. So it will print up the accuracy for us as well. Okay guys, so this is going to take up 5 minutes. I hope so to run this. 5 to 12 minutes it will take us up to run this. So I've written all the code for you guys. Try to write the code and check up the results. I'll keep it running and I'll give you guys the results by tomorrow itself. Right now I'll give you guys the attendance for today's class. So give me a second. I'll give you guys the attendance for today's class in the meanwhile. We had swearing was not arranging less. Okay. Try to do this particular one. Okay, maybe we need to increase the number of layers in that or something like that. But Harsh Prashad, try to do today's particular thing. I think so it should give you 91 or 89% accuracy almost. Okay, so try to do that. And in the meanwhile, I'll give you guys the attendance for today's class. Why so large batch size? Because we are having a lot of images as well, 60,000 images. So you need a larger batch size right over there. So we are taking a 500 batch size at a decent batch size itself. Okay. Let us put it up as D6. Why have you written at the end print score 1? Because if you do score 0, it will give you the losses. You don't want to see the loss. You want to see the accuracy. So accuracy is at score 1. Score 0 will give you the loss. So we don't want the loss. We want the accuracy. Okay, copy. And I'll provide you guys the attendance right now. Please try to fill up the attendance as soon as possible. It will be closed exactly at 9:38. The attendance link will be closed exactly at 9:38, guys. Please start filling it up. Score 1 represents accuracy, that's why, exactly. Does it not increase epochs running time? If you don't do batches, then you will have more number of epochs, right? That does not make any sense. It will still go through that many number of images at the end of the day. Okay, so the attendance is there in the live chat. Please start filling it up. In the meanwhile, I'll just check how many epochs have been done. So 3 of the epochs have been done. It is going to take up a lot of time, guys. Maybe more than 12 minutes, 15 minutes itself. Again, that is the problem of working with images. This is such a small data set and it's taking us so much time, right? Okay, fill up the attendance, guys. We'll meet in our tomorrow's class and we'll continue from right over there. Thank you so much, guys. Thank you, guys. Bye-bye. Bye-bye.